So in the last video, we saw that constraints are the rules that make sure our data satisfies data integrity. And so that we put constraints in place to make sure that the data remains good and accurate. We saw entity integrity, which means that we need to make sure, which is satisfied by making sure that every table has a primary key so that every entry in every row, every record is unique. We saw domain integrity, which is satisfied by specifying the appropriate data type. And then when we were talking about domain integrity, we said that there is also integrity where we want to make sure that the data is accurate for a company. So for example, if they want the hire date of an employee to be between certain dates. Now, that can also be referred to as enterprise constraints or semantic constraints. They are rules that are put by the company, they're business rules that are set, and you as a database administrator need to make sure that they are maintained. So, for example, if we're talking about MCC, we can say that a class can have a maximum size of 35 students, or a teacher can teach a maximum of 6 classes. Okay. So these are called enterprise constraints. They are extra constraints that you put to make sure that the data in your database satisfies the business rules that your company has set or your organization has set. Now, we want to talk more about the relationships that we've talked about before. So remember before we talked about relationships in terms of like one-to-one or one-to-many or many-to-many. Another word that refers to this relationship is connectivity. So if they say, what is the connectivity between two entities or two tables? They're just asking you, what is the relationship type between those two entities? Is it one-to-one, one-to-many, many-to-many? So connectivity is another word that describes the relationship type between entities. Another word that you will see used in database land is cardinality. And cardinality refers to, it's related to connectivity, but it's a little bit more specific. And basically what we want to do is we want to express the minimum and the maximum number of entity occurrences. So remember when we were talking about those lines, so here this is a one-to-many. So what we do in a one-to-many relationship is that we put one line to represent the one relationship, and then we put the many to represent the one relationship. And then we saw these little extra lines that I told you we're going to talk about before. So here, what we're going to do is we're going to say that in this organization or in this institute for teaching, a professor is only allowed to teach up to 4 classes. So the maximum number of classes, yes, it is a one-to-many. A professor can teach many classes, but there is a maximum to how many classes this professor can teach. So a professor can teach a maximum of 4 classes. Now, if they teach, if they don't teach anything, we're not going to hire them. So the minimum number of classes that they can teach is 1. So here we say the cardinality on this side is 1, 4. So a professor can teach a minimum of 1 class and can teach a maximum of 4 classes. Now, looking on the other side, a class, here it's a one-to-many, so we know that in a one-to-many, the opposite now is 1 class can only be taught by 1 professor. So here the cardinality on this side is just 1, 1. A class must be taught basically by 1 professor. The minimum number of professors needed is 1. The maximum number of professors needed is 1. So cardinality just adds more details than the connectivities, just than the one-to-one, one-to-many, and many-to-many relationships that we have been talking about. So cardinality now is going to tell you basically the minimum and maximum. Now, sometimes you'll actually see the numbers written, and sometimes you'll just see 1s and 0s. When you see a 0 here, that means it can, like a 0 can be allowed. So here, the relationship between a teacher and a class is a one-to-many relationship. So a teacher can teach many classes. When we put a 0, we put the circle here, that 0, it means that a teacher can teach no classes up to many classes. So here we are actually allowing this teacher to teach 0 classes. In this picture, we are not allowing the professor to teach a 0. If they're teaching 0, they're not going to be hired. Okay? So this is the difference between that 0 and that one line that are here. Now, the line that connects these two tables in the diagram, that, like we said, that indicates the relationship type. So when I see here a 1 and I see a many, I know that this is a one-to-many relationship. Now, here we see that this is a solid line. It is not dotted. And so when we see a solid line, we say that this is an identifying relationship, a strong relationship. And we talked about strong relationships before, or identifying relationships before, and we said that they are relationships where when I look at this child table, just by looking at the primary key of my table, I can know the parent. So the primary key here, you see that there are 2 columns, 2 attributes that are underlined. So that means this primary key is actually a composite key. It is consisting of 2 attributes, because that's why it's composite. And so the primary key of the order table is an order ID and the customer ID. So if you just tell me the primary key of the order table, I know exactly who the parent is. Why? Because your primary key contains the ID, the primary key of my parent. So we say this is an identifying relationship, because if you give me a primary key, I will tell you who the parent is. Okay. So we draw that as a strong, a solid line. Now, if you see a dotted line, that means it is a non-identifying relationship. It is a weak relationship. So here you see in the primary key in the order table is just an order ID. If you tell me the order ID, there is no way for me, just by looking at the order ID, to know who the customer that ordered, who placed this order is, because that information is not stored in the primary key of my child table. Here, in the identifying relationship, it is stored. You give me the order ID and customer ID. This is the composite primary key. I can tell you who my parent is. It's an identifying relationship. Here, you give me the order ID only. I cannot tell who my parent is. I cannot tell who the customer is that placed this order. I would have to look at other attributes in the table, but just by looking at my primary key, I don't know who my parent is. So we say this is a non-identifying relationship, and so you will see it drawn as a dotted line. And then that 0 just means it's an optional relationship. So when I put a 0 here, means it's optional. The number 0 is actually an option. Having no orders is an option. Teaching no classes is an option. So an optional relationship is represented by a 0 here. This is another example of an optional relationship that is just one-to-one. So here we have an employee can have a spouse. They might have one spouse, that's the maximum, and they might not have a spouse. So here we represent that as a 0. Now, if a relationship is mandatory, you're not going to see a 0 there. You're going to just see a straight line, which is kind of like a 1. Okay, so in this case, if I draw 2 lines here, that means every employee must have a spouse. Okay, so here, if I replace it with a 1, that means it's a mandatory relationship. An employee must have a spouse. And the mandatory relationship, it can show up in a one-to-one. It can show up in a one-to-many relationship. So here we are putting a relationship between an order table and the details of an order. So here we're saying that every order must have at least one detail about it. So an order can have one detail, an order can have many details about it. And here the detail is basically the products that have been ordered. So we're saying that an order ID can have one product, up to many products. So this is a one-to-many relationship. We can't have an order that has 0 products. Will not happen. You can't put an order and not order any products. So this is a mandatory relationship. That is a one-to-many relationship. Now for the classwork, what you're going to do is you're going to practice the on-delete option that we've learned to add when we're adding the foreign key constraints. So it's going to build upon the previous classwork that you did for 3.3. And what I want you to do is I want you to modify your create table statements so that when I delete a student, it's going to cascade the deletion to the child tables so that the foreign keys will get deleted. When you delete a course, it's going to set the foreign key to null. When I delete an exam, I'm going to set the foreign key to null. And what I want you to do is modify the create table statements. You're going to, of course, drop the tables that you created in the previous classwork, and then you're going to recreate the tables with these constraints added. And then I want you to test it to make sure everything is going to work by deleting a student, deleting a course, and deleting an exam. And after you delete a student, I want you to check the student exam grade table and make sure that what happened was that the deletion of the children tables happened. Then I want you to delete a course and check and make sure that the corresponding foreign keys have been set to null. And then delete an exam and again, make sure that the foreign key was set to null. So I'm going to expect here the SQL code in addition to the a picture of the creation of the new tables and 3 pictures of the 3 deletions that you're going to do.